we can't talk about math, we're recording. It's not allowed. All right. Okay, so the reason I said that you could find inverses is because you have found inverses before. So that's why in the instructions it said, you haven't been explicitly taught this because you've never found inverses for this unit, but you have found inverses before. And I did teach you how to undo a log or how to undo an exponent, which means you have all the tools that you needed to do these problems, even though I had never done one with you. So we can do it. We're capable of it. It's just a little bit of a stretch because I'm saying you have the tools, but now do one without somebody showing you. Okay? So it's a little bit of a stretch, but we got it. Okay. Which one should we try? 15, 16, 17, 18? 16? Let's try 16. 16 is a great one to start on because it's like a little bit intimidating, but it's not terribly intimidating. So somebody remind me, when you find an inverse, what is the very first thing you do? You don't even really have to use your brain. You just go, yes, automatically that's what you always do for an inverse. Yes. Switch the x and y. You trade the x and y if you can't do anything else in the problem. With an inverse, you trade the x and y because they always do that. So we're going to do that first. X equals negative 2 e to the y plus 1 minus 3. Now, when you have done that, you have technically found the inverse. It is just not written in the acceptable way that inverses are supposed to be written, that equations are supposed to be written, because mathematicians like for the y to be isolated. So this is the inverse. If we graphed it, it would look like the inverse. It's just not written correctly at this point. Mathematicians are like, nah, man, we want the y to be alone. That's what mathematicians sound like, in case you're wondering. Okay, so now we go through our steps of, first, is there anything you can add or subtract to the other side? Is this feeling familiar? Now that I'm, okay, because we've done this before, right? This is not new, we've done it. This is a new situation. We haven't done it in this situation, but we have done it. Okay, so what could I add or subtract to the other side? The 3. Okay, I can add the 3. So I'm going to plus 3. I'm going to plus 3. Okay. All right. What is my next step? Not that. Think about your order of operations backwards. Divide. Yeah, because my next step is to multiply or divide, right? Next step is to multiply or divide something to the other side. And so the next thing I would do is divide by the negative 2. Makes sense, right? Because we're doing PEMDAS backwards. So now we're going to multiply or divide by negative 2 to the other side. Now, are most mathematicians going to leave a negative 2 on the bottom? Probably not. So what would most mathematicians do with that negative? Yeah, they would probably bring it back up to the top, and if you bring the negative up to the top, how is it going to change the top? It's going to distribute, okay? So if I take the negative off the bottom and I move it to the top, that negative has to go with each term on the top. That is what most mathematicians would do. It's not wrong to leave it on the bottom, it's just uncommon. Does that make sense? Okay, so if I distribute it to the top, what do I get? Okay, so negative x minus 3 and then a positive 2 on the bottom. That is what would happen in most cases. It's not wrong to leave it there, it's just not common. Okay, so at this point now I have the e to the y plus 1. In my order of operations backwards, I am on the step with e, which always tells me either to introduce an exponent or to get rid of an exponent. And this is what you were getting at, Karina. What were you trying to say? Yeah, we're going to log base e the problem, because at this point, the e is the next thing that we want to take care of in the problem. We're trying to get to the point where we can get to the y, and the e is in our way. So to get rid of the e, what's your question? Oh, this is the quiz review. Yeah. So to get rid of the e, we are going to log base e each side. Does that make sense? Log base e. So I'm going to log base e the right side. I'm going to log base e the left side. And when I log base e an e, it goes away. Now, what is a log base e actually? It's actually an ln, okay? So you could write it as a log base e. You're not wrong. That is mathematically accurate. But people would go, huh, well, okay. Okay, I see what you did there. Okay. Did anybody ever teach her that it's an ln? You know? Okay. So we're going to write it as an ln because that's what it is. And you can put this part in parentheses or not, it doesn't matter. Because it's a fraction, we know it's a whole group. So put it in parentheses or not, it does not matter. We know it's a whole group anyway, because it is a parenthesis. All right, and then it equals y plus 1. And so when we did what we just did, we actually busted into already what was grouped in the exponent. The y plus 1 was a group in the exponent, so that was us getting into the parentheses of the problem, the grouping symbols of the problem. So now we are going back to the beginning. We are working our way through the order of operations again. So what do we need to do to get y alone? Subtract 1. All right, so now that the y is alone, we're going to make sure that we write this with the correct notation. So y is alone, and what do we call it? Y inverse, okay, equals ln of negative x minus 3 over 2. And the minus 1 happened after all of that, so the minus 1 gets stuck on the end. Okay, should we try another one? Which one should we try? Yes, 18. Let's do it. Okay, before I get started, the ln is intimidating me, so how could I rewrite the ln before I get started? Log e. Okay, so I'm going to write this as y equals 1/3 log base e. I'm doing this before I even start the problem because it's going to be a little bit easier for me to do. Okay, now I'm ready. What do we do first with inverse problems? Switch the x and the y. Okay, so I'm going to trade my x and my y. Okay, I have found the inverse, but mathematicians don't like this answer. They say, no, that is not proper. So now what do we have to do? Step 1, add or subtract. Okay, and so what are we going to do? Subtract the 1. Okay, so x minus 1 equals 1/3 log base e of y minus 7. Okay. What is the next step? Do you want to divide? Yeah, you could do that. It's a little bit easier. It accomplishes the same thing, but it's a little bit easier for us. So you can multiply or divide during this step. So you would be correct if you said divide by 1/3. That is mathematically accurate. It's not the easiest thing to do. It's a little bit easier to multiply by 3. That's going to be an easier thing for us to handle. So I'm going to say that I will multiply by 3. And over here, I'm going to multiply by 3. And when I multiply by 3, what do I get? I get 3x minus 3 equals log base e of y minus 7. Okay? So next is the step I'm introducing an exponent. I'm doing something exponent related. I'm getting rid of an exponent, something like that. Something exponent. Exponent. Thank you. Okay, yes. So what should I do now? It's going to be with the log e. What am I going to do? Wait, do I put a log e over here? I put a base of e. What do I do with the base of e? Yeah, so I'm going to put an e on each side. I'm turning it into an exponential problem. That's why this is the exponential step, right? I'm turning this into the exponential form. So I'm doing e to the 3x minus 3, e to the log base e, because I know e to the log base e cancels each other out. They're inverses. They're going to undo each other. So these two are gone. Now we have an exponential problem. E to the 3x minus 3 equals y minus 7. So at this point, I've actually done step 3 and step 4. I was able to bust inside those parentheses. So now I'm going back up to the first step and going through my operations again. So what do I do? Add 7. Okay. And so my final answer is going to be y inverse equals e to the 3x minus 10 plus 4 minus 3 plus 7. Okay. Marvelous. So see how even though we hadn't actually learned it before, we could still do it? We knew the steps. Okay. Cool. All right, so we're going to work on the quiz review for a little bit. The quiz is shorter than the quiz review. So I'm thinking we take 45 minutes on the quiz. So this was like a hint, hint, what a great bonus question. Hint, hint. Also, does everyone have their charts to use today? We all have our charts handy. Everybody has their chart. Our charts are available to us. We have our charts. Charts are available. Marvelous. Okay. So go ahead and work on the quiz review. Answer key is up on the back wall. Make sure you're checking your answers. And then the plan is going to be to start the quiz in approximately, class gets out at 2. Is it 2? Class gets out at 2. We're going to start the quiz in approximately 20 minutes. Sound good? Okay, perfect.